Next chapter is work done, and it is defined as dW equal to minus PdV, pressure into volume. We have put a straight line on the top of the D, and why is it? I will explain it later. Suppose this is the PV diagram. In this process volume expansion is going on. In this process volume is decreased, and this is a cyclic process. In this case, the work done is just the area under this curve. In this case, work done is just the area under this curve, and in this case, work done is area under this curve. Okay. Here, volume expansion is going on, so dW is dV is positive, so dW negative, and it is the work done by the system. So, volume expansion is going on. Why the volume expansion is going on? The piston volume expansion is going on means piston is moving upward. Why the piston is moving upward? To make the pressure equal with the surroundings. That means the pressure within the cylinder is high, so volume is increasing to balance with the surroundings. So, the work done is by the system, and for this curve volume is decreased. Why the volume is decreased? The because volume is decreased means pressure is increasing. We are putting force on the piston, so that volume is decreased and pressure is increased. So, it is work done on the system. In this case, in the third one, we see what will be the total work done. Maximum students say the initial state and final state are same, so work done is 0, but that is not the case. You see, the work done amount is the area under this curve, and whether it will be positive or negative, the area under the curve for this curve is this, and for this curve is this. So, area under the volume expansion curve, that is mean this curve is higher than the area under the volume decrease curve. So, the net amount of work dW is negative. So, work done by the system. Repeating, the area for the volume expansion, this means for that curve, is greater than this curve. So, if we minus it, what will be the rest of the amount? This rest of the amount, this area is the rest of the amount. As the area under volume expansion is greater, so work done is negative and is work done by the system. We are now work depends on path. This is a simple example. We are going from initial state to final state. The paths are I, A, F, I, B, F and I to F. Three paths are possible. For I, A, F, the paths are I, A plus A, F. For I, A, what is the work done? I, A, that means the area under this curve is twice P0, and twice V0 minus V0 is minus twice P0 V0. For AF curve, volume is constant, that means dV 0. So, AF curve work done is 0. So, total work done is minus twice P0 V0. As it is negative, it is work done by the system as volume expansion is took place. For IBF curve, IB plus BF. For IB volume is constant, so work done is 0. For BF, it is the area under this curve. Area means pressure is P0, volume is P0. So, it is minus P0 V0. For IF curve, what will be the total work done? Work done is the area under this triangle and is area under this rectangle. For this triangle is area is minus half P0 V0, and this is minus P0 V0 minus 3 by 2 P0 V0. Just follow this maths carefully and minutely. So, what we are getting? We are going from I to F in different paths, from IA path, IBA path. What we are getting? We are getting that in different part work done are different. So, work done is part dependent, and that is why we have put the sign, this sign on dw. This is means it is inexact differential and it depends on path. As work done depends on path, we have given a sign on the top of the w, t, as it indicates, or it is implies that it depends on path. Now, suppose we have to calculate the work done for an ideal gas. So, simple equation W equal to minus P dV, and as you know P is equal to n naught theta by V dV, that means minus n naught theta ln Vf minus Vi. This is another mathematics. V is a function of P theta, as dV is can be expressed as minus kV dP plus beta V d theta, as k and beta already defined. And if it is isothermal process, so dV is equal to minus kV dP because d theta becomes 0 for isothermal process, temperature constant. And if we integrate kV dP, that means becomes kV by 2 Pf square minus P. Simple mathematics, do it yourself, Pf square minus Pf square. Now, in thermodynamics, two parameters are the intensive parameters and extensive parameters. In intensive parameters, if the system is divided into two parts, each with equal mass, then those parameters becomes half, and some of the parameters becomes half and some of the parameters becomes same. If it is half, then it is extensive parameter. If the parameters remains constant, it is intensive parameter. Suppose that means pressure. Suppose we have a chamber containing gas. If we divide the system equally, what will have? Pressure will change? No, pressure will not be changed. Similarly, tension, EMF, intensive parameter. Extensive parameter, volume, length, area, charge. If we divide the container equally, the volume will be half, length will be cut the length, then length will be half, area will be half. So, it is extensive parameter. Now, you know the term adiabatic process. In adiabatic process, what is the meaning of the adiabatic process? Adiabatic process means there will be no heat exchange between system and surroundings. That means the system is not taking heat from the surroundings or rejecting heat to the surroundings. So, what is the adiabatic work done for ideal gas? You know W equal to P dV for adiabatic work. Pv to the power gamma is equal to constant, as you know. That means constant, if we consider constant k, the k V to the power gamma dV, Pi to Vf. Simple mathematics, k 1 by gamma, Vf 1 minus gamma, Vi 1 minus gamma, 1 by 1 minus gamma. We are multiplying k here, k means Pv to the power gamma, that means Pf Vf minus Pi Vi. Follow the equations thoroughly. R 1 by gamma theta f minus theta I, R by gamma minus 1 theta I minus theta f. This is very important equation, and you have to remember for the future to calculate adiabatic work done in case of ideal. That means R 1 by gamma, R by 1 minus gamma theta f minus theta I, or you can remember in this way, R by gamma minus 1 theta I minus theta I. In question it may we've given different forms of equation of a gas, and you have to calculate the work done for that cases. That means you have suppose van der Waals gas, suppose you have given the van der Waals gas, then you have to calculate the work done for van der Waals gas, P plus A by V square, V minus V is equal to RT. And different forms of equations can be given, and you have to calculate from this.